welcome to this 14th video of lesson Similarity of Mathematics Part 2 Standard 10. In previous videos we have learned about similarity of triangles and we have solved sums and proofs on it. Now in this video we are going to see a theorem about areas of similar triangle. How to prove this theorem? Let's see what is the statement of this theorem. When two triangles are similar, okay, when two triangles are similar, first of all, so there should be two triangles and they should be similar. So this is the part which is called as antecedent part of the statement, or we can say the given part. Then what will happen? The ratio of the areas of those triangles, okay, so ratio of areas of those triangles, those similar triangles, is equal to the ratio of the squares of their corresponding sides. Okay, so this ratio is similar, equal to the ratio of their squares of corresponding sides. So let's first draw the figure of two similar triangles and let's write how given and how to and what to prove. So let's draw two triangles such they are equal in the shape, not in the sides. So I have drawn a triangle like this. I can draw the similar triangle with a similar shape. So now these two triangles are roughly in the same shape, because in similar triangles we know the shapes are same, not the sides. Okay. So let's name this triangle, say ABC, and another triangle PQR. Okay. Let's write given. We have drawn the figure and we have written, we have tried two triangles are similar. What are the two triangles? Triangle ABC and triangle PQR. So let's write, sorry, triangle ABC is similar to triangle PQR. So we have written only the shape of same size, similar. Okay. Now when these two triangles are similar, then what? The ratio of areas of those triangles. So to prove ratio of areas, so area of ABC, and we have to take its ratio with area of triangle PQR. So this is the ratio as it is divided one number by the other, and the one number is area of triangle ABC and area of triangle PQR. So ratio of areas of these two triangles is equal to ratio, again we want ratio, so something upon this, squares of their corresponding sides. Okay, squares. So what is the square? What are the corresponding side? Corresponding side of AB, that is first and second letter. Here it is first and second letter of AB, and here it is PQ. So these are the two corresponding sides, and we want ratio of the squares of their corresponding sides. Here it will be AB square upon PQ square. But is it only this pair, one pair of corresponding side? No. As we have three sides, we have three pairs of corresponding sides. So what is the corresponding side with BC? BC is the second and third letter. Here it is QR. So this is BC upon QR. This are the corresponding side. We have taken ratio, but we want ratio of their squares. BC square upon QR square. And what is the remaining side? AC, first and third letter, first and third letter. So it is AC upon its PR, and we want its squares. So this ratio of areas of those two triangles is equal to the squares, the ratio of the squares of corresponding sides. This we have to prove. Okay. So from this statement we have written what is given and what is to prove. Now we have to think how can we prove. So let's write here what is the way in which we have to think and we have to decide how the proof is going to be. Okay. Now here on the left side, or you can say the leftmost side, because we have 1, 2, 3. 3 is equal to sign, and the leftmost side it is area of triangle. So what is the area of triangle ABC? So area of triangle ABC is half into base. Okay. Now what is the base? Base is any one side. Then we want height. Where is the height? We don't have height. So first we have to draw certain height. So let's draw perpendicular from A. Say AD is perpendicular to BC, and similarly here also we will require one height corresponding to BC is the side. If we are taken for a triangle ABC, then QR should be the another triangle corresponding side, and let's draw from perpendicular, say PQR, let's take S. So if we have drawn this, we have to, which we have tried in construction, that, so we have tried in construction that AD is parallel, perpendicular to BC and PS is perpendicular to QR. Okay. So now here we know that this is area of triangle ABC is half into BC into height is AD, and if you are taking ratio of this here, so upon area of triangle PQR, it is half into QR into PS. Now we know half gets cancelled. Actually we have learned about these two triangles, area of these two triangles. Any two triangles is equal to its ratio of their base and corresponding height, product of the base and corresponding heights. We already have seen this property in very first video of based on the lesson similarity. Okay, now what is the speciality of these two triangles? These two triangles are not any two triangles. These two triangles are similar. So how can that word similar or the fact similar will help us to prove not only this, but it is say BC square upon QR square. So means here we want BC upon QR its square. So if we split this BC upon QR and this here if we take AD upon PS. Okay. So this product we have split it in these two ratios. So here we are getting 1 BC upon QR, but we don't want only BC and QR, we want its square. Means this can we have to replace, we have to see, can we replace this AD upon PS by BC upon QR? If we can replace this AD upon PS as BC upon this QR, means if we can show that AD upon PS, this is equal to BC upon QR. If we can show this, then this can be replaced by same BC upon QR, and then you can get AD BC into PC and QR into QR, that is BC square upon QR square. So we need to think, can we show this altitudes of two similar triangles are in the correspondence or in the proportion with their sides. Okay, so when we can show these two sides are, these two altitudes are in proportion with the corresponding sides or not. For that we have to show two triangles similar, where will we have this sides BC and QR or PS. Okay, so what about this AD and BC? They are not in same triangle. So instead of BC, what we can do, we can, now we know being these two triangles are similar, ABC and PQR, we know that it's all three sides are in proportion. So AB upon BC, sorry, not AB upon BC, it's AB upon PQ is equal to BC upon QR and AC upon PR. We know that these two triangles are similar, so its sides are going to be in proportion. Now we want to show BC and QR and this to be equal. So can we show this AD upon PS is also equal to this, or it can be equal to any one of this. Okay, if we can show this all four ratios equal, our target can be achieved. Okay, so how to do? Now as AD and BC is not in the same triangle, we have to think about the rest ratios also. So now what we can do? Say let's take a triangle AD, such triangle where AD is one of the side. Either we can select this left side triangles or the right side triangles. Any one we can select. Let's select, so we have selected this triangle as number 1 and this as triangle number 2. Okay, so can we prove these two triangles similar? To prove this triangle similar, at least we need to prove two angles to be congruent. Okay, now in here if you see that angle D is 90 degree as well as angle S is also 90 degree. Okay, so one we got this angle is congruent, and what about rest? Now we can see that angle B is angle of the triangle ABC and angle Q is angle of triangle PQR. So these two angles are corresponding angles of two similar triangles. Hence we can show these two angles congruent. Okay, so we can show these two smaller triangles similar. If we select the bigger one, there also we can do the same. That angle D is congruent with S and angle C can be congruent with angle R because it is angles of the corresponding angles of the similar triangle. So either this pair or the bigger angle triangle pair we can select, and we can prove this they are similar. Okay, when these two triangles will be similar, so what we will do? We will try to prove angle ABD similar to triangle PQS. Okay, where we can get corresponding sides as AB upon PQ is equal to, we will select this AD, which is altitude of the bigger triangle, AD upon PS. Okay, so here we got that the side ratio of the altitudes AD upon PS is equal to one of the side of corresponding side of triangle ABC and PQR. So here see, this and this we have proved equal. Correct? So now if these two are equal, then of course we can state this statement, and from this we can prove this part and this part, and then we can show it's, we can get it square. BC upon QR into BC upon QR, we can get it BC square upon QR square. So that is the way in which we have to go. Okay, so after this understanding what we have to do actually, now we will start the proof part. Okay, generally the thought process whatever we have to go in its reverse order. Means first we will try to prove these two triangles similar. For that we will require the bigger triangles and these two angles. Okay, so let's try in proof part now. In triangle ABC, or you can start directly that let's given it is a triangle. We are not proving this, we will prove this afterwards. Let's use this given statement. In triangle ABC is similar to triangle PQR. Now as you have understood what is to be done at this part, I have going to write over here. So let me rub this part over. Okay. So this is given part over here. From this let's write, therefore angle B we want. So angle ABC is congruent to angle PQR. Say statement number 1. It is the corresponding angle of similar triangle. Corresponding angle of similar triangle. They are congruent. And one more thing let's write, that corresponding sides AB upon PQ is equal to BC upon QR is equal to AC upon PR. Okay. Statement number 2. Corresponding sides of similar triangle. Okay. This is the thing. Now let's try to prove this triangle. Now in triangle ABD, which we have selected, and triangle PQS, the two shaded triangles, first and second, where we are going to prove angle B is congruent to angle Q. Okay, now what is the remaining? A and D, it's remaining here, and for Q, P and S. So these two angles are nothing but, this is same angle ABC and PQR. ABD is equal to ABC and PQS is equal to PQR. So this we can say from 1, where we have shown these two triangles congruent. Okay, and angle, which one? D, is congruent to angle S, which are both 90. We have selected D here, so remaining is AB. Take it here, left and right. S is right angle, so PQ is remaining. Put it one to the left and one to the right of S. So here each 90 degree. Correct. Of course, now let me rub the other part of the board. Here, I know this board is a little bit smaller for this theorem. Let me adjust over here. And therefore, triangle ABD is similar to triangle PQS by AA test. Okay. So after proving this, let's write the corresponding sides of these two triangles, which we can get it as AB upon PQ is equal to AD upon PS. As we have decided, we are going to select this first and second and the first and third. We are not going to require BD part and the QS part. Okay. So here statement number, we have taken statement number 1 and 2. So let's take statement number 3, and the reason is corresponding sides of similar triangle. Okay. Now from statement number 1, that here these three sides are in proportion and where AB is common in both. Okay. So from this 2 and 3 we can write all these 3 ratios plus this AD and PS. These all 4 ratios are equal. So from 1 and 3, therefore we can say AB upon PQ is equal to BC upon QR is equal to AC upon PR is equal to AD upon PS. Statement number 4, and the reason is from 2 and 3. The reason is going to be from 2 and 3 statement. Okay. Now, after this, whatever we require, I will rub this this part from given, because now we have this statement with us. Now we can prove with the help of that statement. So let me rub this part. Now to start the next part of the proof, now we want ratio of their areas. Okay. Therefore, now area of triangle ABC upon area of triangle PQR, it is now area of any two triangles are equal to that base into the height BC into AD upon QR into PS. So by the property that it is ratio of areas of any two triangles is equal to ratio of their product of base and corresponding heights. Okay. So by that property, of course, then we will say that therefore BC upon QR into AD upon PS. Okay. Now this AD upon PS, which is equal to BC upon QR from statement number 4. So we will replace that. So BC upon QR as it is and AD upon PS, this part we will replace it as BC upon QR, and here we write from statement number 4. Okay, and therefore we can say that it is equal to your BC square upon QR square. Okay, so here let's write here area of triangle ABC upon area of triangle PQR. So we got this areas of these two similar triangles is equal to the square of their corresponding side. But here only we have only one pair of sides. To write the other pair, so let's write statement number 5 over here. Now from this statement, and that all these three sides are equal, sorry, not equal, but their ratios are equal. So we can say that from 4 and 5, that area of triangle ABC upon area of triangle PQR, as it is equal to the BC square upon QR square, but we know that, see this we can say that it is BC upon QR the whole square, correct? So BC upon QR can be replaced by AB upon PQ and we can take it square. So here we can say AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square. This we are stated from 4 and 5. So from these two statements we can say the required statement which we want to prove is proved. Okay. So this is our answer statement or answer. Hence the always we write the last statement that answer statement is always. Hence the given statement is proved. Okay. So like this we have proved this very important theorem from the lesson similarity, areas of similar triangle. In short, it can be called as AST. Okay, if you have understood the way in which I have taught you how to prove. See, just explaining whatever given in the textbook is very easy, but my always point is always explain in such a way that you should be able to what is the thought process behind it. And once you understand the thought process, writing and presentation part is very much easy. So that core part of the any proof or any theorem is to understand the thinking process, how we have to decide that in which way we are going to prove it. That is most important part, and I hope you have understood this technique of teaching the proofs, theorems. Please give me likes, comments, and yes, don't forget to forward it to your friends so they will also learn in this new way. And if you are not yet subscribed to the channel, please subscribe. Thank you very much. In the next videos, we will see the sums based on this theorem. Thank you.